Welcome to Groundwork. It's a podcast from McClanahan Corporation to talk about key material processing topics, from agricultural to mining to material recycling. We'll discuss the best way to process the raw materials that power the world, because we know if it's not grown, it has to be mined. Hello, I'm Geordie Edmiston with McClanahan Corporation. I've been with McClanahan Corporation going on 25 years now. Mostly in the mining side of things, a bunch of different roles with McClanahan Corporation. Right now, I'm currently the global product manager for crushing and rotary equipment. With me today is Tyler Piper. I'll turn it over to him and let Tyler introduce himself.
Hi, I'm Tyler Piper. I've been with McClanahan for 20 years. My primary background has been rotary equipment design. I've done that for about 15 years. These last 5 years, I've been the engineering director for our dry processing group. And my group handles our roll crusher lines, jaw crushers, impactors. We've got several lines of feeders, drag chain feeders, apron feeders. We also do some vibratory screens, as well as our rotary equipment lines.
Today, we're going to be looking at, initially we're going to look at rotary scrubbers, but then also we're going to look at some rotary equipment designs as well. Since they're very similar in design, but they all have their unique design features. So, what is a rotary scrubber?
Geordie, a scrubber is basically a big washing machine, big rotating cylinder used to clean contaminants, soft processed material. The goal is for the material to come out clean on the other end, so go on for further processing and become a sellable product for our customers.
I know we use these in multiple industries. We're looking at aggregate, iron ore, phosphates, oil sands,
bauxite.
But we do have to be maybe a little cognizant of the type of clays we're putting into rotary scrubbers. They're more designed for light loamy type clays, not the tacky type clays. There's a test we can do. We call it the soak test. Take a 5-gallon bucket of water, put your material in, let it sit 24 hours undisturbed. Next day you get out and you take a look at it. Is it dissolved and laying in the bottom of the bucket? Hey, that's a good indication that a rotary scrubber will work for that. Now, if you pick it up and it's still solid, competent material, it's not going to do real well. It'll pretty much turn a scrubber into maybe an agglomerator of some type, right? You got to have a small lump go in, pick up other material. It's going to come out bigger than what it went in. When we're talking about, designing these for the application, we'd like to get an application data sheet into the customer's hands. We're looking for, capacities, feed size, residence times, maybe stuff of that nature. When you have your engineering guys looking at designing the scrubbers, what all information do they need?
Yeah, the big one is retention time, and also the capacity, what you want to put through the machine, Geordie. Those two items are the main factors on what will drive the size of the equipment. So how long does it need to be in there, and how much you're trying to put through there? And it's really a volumetric calculation that the drum can only hold so much material and how long it needs to be there, and that drives what size the machine will be to do its job.
Exactly. We're not like a big box store where you walk in and buy something off the shelf and put it into your application. We design per the customer's wants and needs. There's different types of wear liners we can put in for them. There's different drive configurations. Where in the process are we going to find the rotary scrubber?
So typically your scrubbers will be after your primary crushing and screening phase. So we'll take material out of the primary crusher. It'll go into the scrubber along with processed water. Scrubber will rotate, designed with lifters inside. It'll agitate the material along with the water. breaks down all the clays and contaminants. Hopefully clean material comes out the other end, and it could go on for further secondary processing.
So what are the, we talk about residence times. We have lifters in there. The lifters are adjustables. We have weirs we can add. What all can we do to either increase or decrease residence time within the scrubbers?
Residence time is really driven by your weir height, and the weir height is basically a dam inside the cylinder. And then the other factor in that is your feed opening. And your volume of material inside the drum is essentially to the top of your weir to the bottom of the feed opening. And that drives how much material is in there. So if you need more residence time, you need a higher dam or higher weir. When you're getting deep material bed depths, then obviously you need more horsepower. But really, it's that charge of material that drives your residence time.
Okay. I'm going to come back to the horsepower side of things, but internally to the scrubber, I know we can use different type of wear materials. Customers might have a preference to whether they want steel, rubber, or we use any type of CCO, tungsten carbide. And I know that we provide drums with various types of wear material within the same drum, depending on what we're expecting to be occurring in the drum as it moves down through the cylinder. So, what all wear materials can we provide?
So, the two basic liner packages, one, we do a rubber line package. Many of our scrubbers are designed with this rubber package. It's usually 2 to 3 inch thick, 60 durometer rubber with a steel backing. We use rubber lifter bars to clamp those liners into place. We also do standard AR plate to line the scrubbers as well. These are bolted in. And then you mentioned that we do some overlay and some of the more abrasive applications. We'll use overlay to get a little bit better wear life out of the lining package. The other thing we'll do, because the finer material tends to like to find the gaps in liners and get down to the foundation of the cylinder itself, we can also do a thin rubber lining on the shell itself to help protect the cylinder and extend the life of the machine in that way.
Yeah. Okay. We make these drums anywhere from 6 feet diameter, 10 feet long, to 16 feet diameter, 60 foot long. So obviously we have different drive configurations. We have friction drives, we have chain drives, we have gear and pinion drives, and hydraulic drives, and various horsepowers. Like you had mentioned earlier, when your engineers are designing, we're taking into account all of these different applications and the details of each application to design our power requirements. Also, what are we looking for when we're designing the drive configuration?
Yeah, so first we need to settle on how much power we need, and that can kind of drive, what style drive we pick. You had mentioned chain and sprocket drives. The majority of our rotary equipment are going to be chain and sprocket drives. That has horsepower limits. So if you get, say, roughly above 800 horsepower, we got to look at a different option. We've done gear and pinions. We've also done hydraulics. Some customers prefer hydraulic drives, so in that case, we'll do a hydraulic drive for them. And then the lighter duty machines, we have done some friction drives. The trunnions are coated in a urethane, and we mount a gear motor directly to the trunnion shaft, and it's driven by friction from the roller that is the drum sits directly on.
So, talking these different drives and talking the trunnions, alignment is key in rotary equipment. You want to make sure it's properly aligned. It's going to extend the wear life of the components, extend the wear life of the equipment itself. We have 4-point design, 3-point design. Is one better than the other, or are they pretty much equal?
I'd say they're pretty much equal. The reason we go 3-point design would be for a hydraulic drive. We have a traditional trunnion base with 2 trunnion rollers at the feed end, and then to mount the motor, we need a drive shaft in the dead center of the drum at the discharge end. So you only need the 2 rollers to support it. For the traditional chain and sprocket or gear and pinion or even friction drive, we have 2 trunnion bases, support the drum with 4 rollers. In either case, alignment is key. You need to stay on top of that, keep the thing well aligned. It's something you should be checking, weekly. Visually, you should be checking it daily. If you have a well-aligned machine, it's going to last a long time. But if you don't stay on top of it, you can create some headaches for yourself by doing some damage to not only your trunnions, but maybe even your cylinder tire as well.
Yeah, I mean, a key alignment, you really want to see that drum floating back and forth between your thrust rollers.
Yep, absolutely.
Nice. It'll go down, it'll kiss one, it'll come back up, it'll kiss the feed end, the discharge end. It just floats, so to speak.
Absolutely.
That helps any wear on your trunnions or your cylinder tires. And, if it's riding hard at one end or another, then you really need to get that aligned.
Absolutely. If you're riding hard, you're going to get vibration issues. Vibration issues will cause flat spots on your trunnions, which will transfer over to your cylinder tires, which once you get flat spots, they don't go away. And then you'll have to do a tire grind to get everything, back in order. And that could be costly.
Yeah, and it's hard to do in situ too. There's some companies out there that will do it in situ, but most of the time you need to get the cylinder off of the machine, out of the machine, and a whole raft of other complications when you start doing that. I participated in doing some scrubber alignments. They're interesting. It's very, very technical and key to get them done correctly. But checking them in the field and making sure they're done and operating properly is really going to extend the wear life of the equipment.
Yep, absolutely. And alignments are, I'll say, tedious and very. It doesn't require much adjustment on a trunnion roller. I'm talking thousandths of an inch to go from out of alignment to in alignment. So when you're doing those procedures, it's something you got to be aware of. How much you're moving trunnions and make sure you're keeping everything in order.
Make that adjustment, get the machine running again, check it out, see how it's moving, and make little adjustments at a time.
Yeah, we don't recommend any more than 5 thousandths at a time. I've been out in the field where 2 thousandths made all the difference.
Yeah.
To get the thing back in order.
And we can provide that service as well as we can also supply an alignment kit with the equipment.
Yep,
so
we sell an alignment kit. We got a team of field service engineers or field service folks that are very capable of doing alignments. And then also our manuals always touch on the alignment procedures themselves, and they're pretty well done. So pretty self-explanatory if you get into the manual.
So let's take a look at a couple applications. We have a limestone application down in Texas, 16 by 60, big machine, gear and pinion driven, I should say, 2,000 tons an hour. So you remember that machine?
Yeah, absolutely. I know that one very well.
Some of the factors that came into play when we were deciding, the type of drive configuration and all that.
So initially, that's an interesting project because we were replacing an existing machine that was gear and pinion, and we could actually converted it over to chain and sprocket. And because we were replacing an existing machine, we were reusing their old drive. So we were kind of shoehorned in on how much horsepower we had. It was 800 horsepower drive. That's all we had. Customer was requiring 2,200 tons per hour, which is pushing the limits of that 800 horsepower. So we were able to work with the customer down there and sort of fine tune that machine to be able to, one, get the 2,200 tons per hour through the machine and also get a clean product. Now, it took a few iterations, and our customer was willing to work with us on that one. Um, Initially, we were concerned about getting material through the drum, so we added all these diagonal lifters to help push the material through the drum. Um, and what we found when we started up, we were pushing it through too fast, and the material was still dirty coming out the other end. So we pivoted and started going with some straight lifters, cut down the height of those lifters to try to save some horsepower, cut down the height of the weir to also save some horsepower. And then with the straight lifter configuration, we've been able to successfully now for several years meet that 2,200 ton per hour requirement, all while still using that 800 horsepower motor.
Yeah, and that's something you said there. It means even though we send the equipment out of the shop to the customer in a certain configuration, you still have to do some fine tuning on site.
Absolutely.
We look at it in our rotor breakers. Are we advancing the material too quickly? Or is it not going through fast enough? So there are on-site adjustments that need to be made to fine-tune the equipment and get it running to the customer's expectation.
Absolutely. Yeah. Geordie, every application's a little bit different. You might be doing the same exact thing at two different places, but the machine and the material is just not going to, behave the same all the time. So it does require some manipulation after installation to sort of optimize for each specific customer.
Yeah, and I think that's where it's key on the front end that we get as much details as we can from the customer, and also get their input during the design process and make sure they buy into what we want to offer.
Yep.
So
Yeah, getting that feedback from customers is great. It helps us as engineers for future designs. You're able to extract a lot of very useful info when you get feedback from customers. And this particular scrubber down in Texas, the customer was very involved in the design of that. They were weekly conference calls with them, going over the internal configuration. Just great questions from them that really drove that design, because it is a pretty unique machine. It's got a lot of bells and whistles, and the customer was very involved in helping us develop that.
yeah, and I think when you get their buy-in to it, it's just not like you're force feeding them. You have their buy-in; they are more on board with it, and I think the whole process runs a lot smoother when you do that.
Yeah,
So
absolutely. They're buying in. They know what they're getting.
they
They
have
know what to
ownership.
expect,
Yep,
and they know what changes may need to be made based on what happens when it finally does start processing material.
sure. So let's move on. Look at the iron ore project we have in Western Australia. This is a 3-point design, hydraulically driven. Once again, 2,000 tons per hour. So what was the deciding factor in going from like a gear and pinion we're using in Texas to a hydraulic drive that we're using in Australia?
Yeah, so as I had mentioned earlier, once you get up above 800 horsepower or so, you got to look at other options for the drive, and those two options are gear and pinion or a hydraulic drive. In Western Australia, the customer's preference was the hydraulically driven machine. Really, it's up to customer at that point which style they want to go with. This customer was comfortable with hydraulics, so that's the route that we chose for them.
I know a lot of mine sites, because we can offer different drive configurations in other machine, equipment as well. Um, and some mines just do not like and they shy away from hydraulics. So if you have the customers buy in on hydraulics and they really want hydraulics, I think it's pretty much bomb-proof in my opinion.
Yep, it's a great drive, very reliable. You just need the end users to be comfortable with it.
Yep, know how to service and work on it. So shifting gears a little bit, we're talking scrubbers, iron ore, and limestone and stuff, but we're also we have very similar designed equipment in the oil sands running.
Yeah, so the oil sand's a little different. What they're doing there, uh, they're they're essentially extracting the oil. They mine the oil sands. put it directly through the primary crusher. They put it into our rotary wet screen, mix it with the hot process water, which breaks down the big clumps of oil sands. They are screened out through our screening section to go on for further processing.
Discharge the rock out
Yeah,
the back.
and then all the junk rock is what discharges out the end, and that just goes into a pile, and then everything that falls through the screening area is further processed and eventually becomes barrels of synthetic crude oil.
We've had multiple generations of rotary equipment running in the oil sands, and it's evolved over time with the customers buy-in, once again, an input. We started out with 12 by 48, 12 foot diameter, 48 foot long, and we're up to 16 by 60s right now, pushing 8,000 tons an hour.
I think it's 8,300 tons per hour through those machines.
Yeah,
we've actually worked with them recently on upping that to 10,000 tons per hour.
Guy is hogging a lot through a machine, So, and that's a gear opinion, but I think it was not. I have it in kilowatts. It's like 1,500 kilowatts, so about 2,000 horsepower drive.
Yeah. So the 16 by 60, which is the largest machine McClanahan's ever built. We built 3 of them. That is a 200 horsepower, 2,000 horsepower drive, which is pretty massive.
That's huge. I saw it out here in the shop. You had to get a ladder to get up onto the base of the drive. So it's big stuff. It's impressive. So, just talking about McClanahan Corporation in general, we're not a box store type company. We work with our customers. We appreciate and ask the customer to be involved with the designs and the operational details of everything. So the end goal is to send that equipment out and have it up and running to the customer's expectation pretty much right off the bat. So the more we can do on the sales side of things just helps the engineering side to design the equipment good to go the first time. Anything else you want to add to the conversation?
I'll just echo your thoughts that we aren't a big box store, especially with rotary equipment. Every application is unique. We're essentially designing each piece of equipment from the ground up every single time we take a rotary order. And like you had mentioned, the more info that we can get up front, the better off we are with our initial supply, being able to do the job that it's required to do.
All right. Well, thank you for listening to Groundwork, a McClanahan podcast. Be sure to subscribe on your favorite listening app for new episodes and follow McClanahan on social media for more content. Thanks again.
Thank you, Geordie.